Crash course on computer science, data structures and algorithms. Explore data structures such as arrays, linked lists, and trees, and learn about algorithm design and analysis. Certainly, let's dive into a crash course on computer science, data structures and algorithms. Data structures are a way of organizing and storing data in a computer program. Algorithms are the set of rules or steps that must be followed to solve a particular problem. In this crash course, we'll explore different data structures such as arrays, linked lists, and trees, and learn about algorithm design and analysis. One interesting example that demonstrates the importance of data structures and algorithms is the game of chess. Chess is a game that has been played for centuries, and it requires a lot of strategy and thinking ahead. In fact, some of the most powerful chess-playing programs use sophisticated algorithms and data structures to make decisions and moves. One such program is Deep Blue, which was developed by IBM in the 1990s. Deep Blue was designed to analyze all possible moves and outcomes in a game of chess and choose the best one. To do this, Deep Blue used advanced data structures such as hash tables and algorithms such as alpha-beta pruning to efficiently search through all possible moves. Now, let's take a look at the top 12 popular data structures and algorithms. 1. Arrays. An array is a collection of elements, all of the same data type, stored in contiguous memory locations. 2. Linked lists. A linked list is a linear data structure where each element, called a node, points to the next node in the list. 3. Stacks. A stack is a linear data structure that follows the last in first out, LIFO, principle, where the last element added is the first one to be removed. 4. Queues. A queue is a linear data structure that follows the first in first out, FIFO, principle, where the first element added is the first one to be removed. 5. Trees. A tree is a nonlinear data structure where each element, called a node, has a parent and 0 or more children. 6. Graphs. A graph is a nonlinear data structure consisting of nodes and edges that connect them. 7. Hash tables. A hash table is a data structure that stores keys and their corresponding values, allowing for constant time retrieval. 8. Heaps. A heap is a binary tree data structure that follows the heap property, where the parent node is greater than or equal to its children, max heap, or less than or equal to its children, min heap. 9. Sorting algorithms. Sorting algorithms are used to sort a collection of elements in a specific order, such as alphabetical or numerical order. 10. Searching algorithms. Searching algorithms are used to find a specific element in a collection of elements. 11. Dynamic programming. Dynamic programming is a method for solving complex problems by breaking them down into simpler subproblems and storing the solutions to those subproblems. 12. Greedy algorithms. Greedy algorithms are a method for solving optimization problems by making the locally optimal choice at each step, with the hope of finding a global optimum. These are just a few examples of the many data structures and algorithms out there. Each one has its own strengths and weaknesses, and choosing the right one for a particular problem requires careful consideration. In summary, data structures and algorithms are fundamental concepts in computer science that are essential for solving complex problems. By understanding different data structures and algorithms, programmers can create efficient and effective software solutions. And now, as promised, here's a poem about data structures and algorithms. In the world of code, we must beware of data structures and algorithms, a pair so rare. Arrays and linked lists, stacks and queues. Trees and graphs, each with its own unique use. Hash tables for fast retrieval. Heaps for sorting, always so vital. Dynamic programming to break down complex problems, with solutions that astound. Greedy algorithms to optimize. And searching algorithms to help us find the elements we need in no time. Data structures and algorithms, a powerful team. Creating software solutions that fulfill a dream. So take the time to learn and understand these concepts that shape the digital land. For with them, you can achieve great things and unlock the potential that programming brings. In conclusion, data structures and algorithms are an essential part of computer science, and understanding them is crucial for any programmer. With this crash course, we've explored the basics of data structures such as arrays, linked lists, and trees, as well as algorithms such as sorting, searching, and dynamic programming. We've also seen how these concepts can be used in real-world applications such as chess-playing programs. Whether you're a beginner or an experienced programmer, learning more about data structures and algorithms can help you become a more effective problem solver and create better software solutions. So don't be afraid to dive in and explore this exciting field. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html?8=7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for support our AnHub Metaverse channel, and please watch more interesting videos here.